It's been more than 40 years, an epic voyage across the stars. Now, Voyager 2 has finally crossed the border of our solar system and stepped into the great unknown. For 7 long months, there was nothing. Just silence, no beeps, no blinks. It was as if the spacecraft had simply vanished, drifting alone through interstellar space, forgotten. After decades of faithfully transmitting data from the edge of everything we know, NASA feared the inevitable. Had Voyager 2, launched in 1977, finally gone quiet for good? And then, just when hope was fading, a signal broke through the void. Not a blip, a full, clear transmission. And what it said left scientists stunned. Was it a glitch? Or did Voyager 2 encounter something out there, something we've always wondered about but never dared confirm? Stick around till the end as we unpack this cosmic mystery. From Earth to the edge of forever, picture this. A spacecraft launched when floppy disks were cutting edge, now sending signals from a region where the sun is just another star. It all began on August 20th, 1977. Inside NASA's Jet Propulsion Laboratory, engineers rolled out a gleaming spacecraft, Voyager 2, and loaded it onto a Titan II-IE rocket. With fingers crossed, they watched it blast off, heading for the outer planets. The mission? Almost impossible. Explore Jupiter, Saturn, Uranus, and Neptune, then go even farther, out beyond the reach of the sun. It had just 69 kilobytes of memory, less than what's in a basic calculator today, and a whisper of solar energy. Yet it was packed with everything it needed to survive deep space. 16 hydrazine thrusters kept it steady, correcting its course when needed. A gyroscope and star tracker locked onto both the sun and a bright star named Canopus, helping it stay oriented. If any part failed, there was a backup ready to take over, like a cosmic road trip with every spare part packed just in case. Power didn't come from solar panels, they'd be useless that far out. Instead, Voyager 2 ran on 3 radioisotope thermoelectric generators, or RTGs. These devices quietly converted heat from decaying plutonium into electricity. They were built to last until around 2025, and here we are, Voyager 2, still ticking, still pushing the boundaries. And it wasn't just surviving, it was exploring. Voyager 2 carried 11 scientific instruments, a magnetometer to study magnetic fields, a cosmic ray detector, ultraviolet spectrometers to analyze atmospheres, and a camera system that captured some of the most iconic space images in history. But getting those images home was no small feat. With just 69 kilobytes of storage and a data rate of 115 bits per second, each photo took hours to transmit across the stars. Still, Voyager 2 managed it, one slow, steady signal at a time. Back in April, Voyager 2 came dangerously close to going silent forever. Its main radio receiver failed without warning. Thankfully, the backup kicked in, only to suffer a glitch of its own when a tiny capacitor gave out. Suddenly, NASA had to communicate with the spacecraft using an extremely narrow frequency window, one so delicate it could shift with the Earth's spin, temperature changes, or even bursts of solar activity. No autopilot here, just pure brainpower. Engineers worked out the exact tuning for every signal by hand, turning every message into a high-stakes calculation. The scare was real, but it also proved why Voyager 2 was built with duplicate systems for its most crucial parts, and just how quick thinking the JPL team could be in a pinch. Fast forward to July 1979. Voyager 2's date with Jupiter. While Voyager 1 had already flown past the gas giant earlier that year and captured unforgettable close-up images, Voyager 2 took a slightly different route, wider, slower, and perfectly positioned to soak in data Voyager 1 missed. It hovered longer near the planet's rings and the swirling edge of its magnetic field. The two spacecraft, working in tandem, revealed something truly extraordinary. The first active volcano ever seen outside Earth, erupting on the moon Io. Picture it. Massive fountains of lava exploding into space, sulfur plumes glowing like fireflies against Jupiter's shadow. Though it wasn't as close, Voyager 2 gathered fresh details on the eruption. measuring temperatures, velocities, and shock waves to give scientists a fuller view of Io's stormy volcanic heart. But that wasn't all. Voyager 2's instruments tracked faint, shifting rings around Jupiter and mapped its moons in greater detail. Each packet of data it beamed home was a tiny triumph, especially after the near-fatal glitch in April. Far from being a runner-up to Voyager 1's spotlight moment, Voyager 2 delivered the perfect complement. Where Voyager 1 captured the drama, Voyager 2 brought depth. Together they told a complete story, a cosmic duet of discovery. 17,000 snapshots from a giant. On July 9, 1979, Voyager 2 drew closest to Jupiter, flying about 400,000 miles above its churning clouds. Back on Earth, the Deep Space Network dishes waited with bated breath. At 22:29 UT, the first images began to trickle in. Not just more of the same, new rings, new moons, and surprising twists in the planet's turbulent weather. One of the biggest shocks: Jupiter's ring system was far more complex than anyone thought. Voyager 2 also uncovered two hidden moons, later named Mate and Adra, that orbited closer to the planet than anyone had predicted. By the time the flyby was over, Voyager 2 had sent back around 17,000 new images, including time-lapse shots of the Great Red Spot, Jupiter's enormous centuries-old storm. Earlier missions like Pioneer 10 and 11 saw it as a fixed feature, but Voyager 2 showed it changing shape, drifting in color, and revealing just how alive Jupiter's atmosphere really is. Behind all this data were tireless teams on Earth. Scientists and engineers worked around the clock, uploading precise command sequences to capture the perfect angle or adjust for solar interference. With every command taking nearly an hour to reach the craft, there were no second chances. Miss your timing, and a rare volcano eruption or weather event was lost forever. Voyager 2 didn't just take pictures. It rewrote everything we thought we knew about the outer planets. After its dazzling flyby of Saturn in 1981, Voyager 2 quietly sailed through the dark for nearly 4.5 years, making its slow, steady way to Uranus. On paper, it may have looked like nothing much was happening. But behind the scenes, NASA's engineers were anything but idle. They fine-tuned the spacecraft's software, squeezing every ounce of performance out of its aging systems. Meanwhile, back on Earth, they upgraded the massive antennas of the Deep Space Network, sharpening their ability to pick up Voyager's increasingly faint whispers from space. These careful adjustments paid off. By the time Voyager 2 neared Uranus, it was able to beam back as many as 200 photos a day, despite the planet's weak sunlight and enormous distance. On January 24, 1986, the spacecraft reached its target, flying just 81,600 kilometers above Uranus's cloud tops. It was close enough to peer through the planet's dreamy blue-green atmosphere and get a good look at its strange tilt, nearly 98 degrees off kilter. That extreme lean means Uranus spends decades with one pole bathing in sunlight while the other is cast into deep night. But the surprises didn't stop there. Voyager 2 spotted a system of 9 ghostly rings that Earth-based telescopes could barely detect. Its instruments picked up methane clouds floating high above the clouds and measured shockingly fast winds, racing at nearly 900 kilometers per hour around the planet's midsection. Despite being deep in uncharted territory, the spacecraft remained in good shape. A mechanical glitch that once threatened its camera system never returned, and its nuclear-powered generators were still humming along, providing just enough energy to keep the instruments alive. Once the Uranus encounter was complete, Voyager 2 turned its high-gain antenna back toward Earth and continued onward, next stop, Neptune, in August of 1989. By then, Voyager 2 was about to visit the most distant planet ever explored. Pluto still held the title of 9th planet, but at that moment it was actually inside Neptune's orbit. Since its discovery in 1846 by Johann Galle, guided by Urbain Le Verrier's predictions, Neptune had remained a mystery to astronomers. Voyager 2 was about to change that. As the probe drew close, Neptune turned out to be far more dynamic than anyone imagined. Just slightly smaller than Uranus, It was nevertheless a planet full of storms, movement, and drama. Voyager 2 had already discovered 10 new moons around Uranus, but Neptune's satellites were stranger. Before Voyager, only 2 were known: Triton, discovered just weeks after Neptune itself, and Nereid, found in 1949. But while Uranus's moons orbit neatly around its equator, Triton moves in the opposite direction, with a steep retrograde path tilted at 157 degrees. Nereid, meanwhile, travels on an elongated orbit that takes almost a full year to circle Neptune once. When Voyager 2's images came back, they showed that Triton was no frozen relic. It was alive. Its surface was covered in bizarre cantaloupe terrain, and towering geysers of nitrogen gas erupted into space. Even in the icy darkness of the outer solar system, geology wasn't dead. Triton's strange orbit suggested it wasn't born around Neptune. It may have once been a dwarf planet, wandering the Kuiper Belt before being caught and captured by Neptune's gravity. The chaos from that capture likely disrupted or destroyed other moons, leaving Nereid on its lopsided path, a survivor of that ancient cosmic upheaval. After the Neptune flyby, Voyager 2 continued its long journey outward toward the very edge of the Sun's influence. And in August 2018, more than 40 years after launch, it finally crossed the heliopause, the invisible line where the solar wind gives way to interstellar space. But rather than finding a solid boundary, Voyager 2 encountered a restless frontier, full of fluctuating magnetic fields and cosmic rays. Its instruments even picked up spikes in plasma density, revealing that this edge of the solar system is more like a living, breathing membrane than a wall. Then the silence. For decades, Voyager 2 had faithfully sent back its distant signals, tiny but triumphant pings that reached across the void like an old friend saying, "I'm still here." But in March 2020, something changed. The 70-meter dish at NASA's Goldstone facility went silent. At first, the team chalked it up to routine maintenance, but then the days turned into weeks, and still no signal. Engineers double-checked equipment, reloaded software, even switched antennas. Nothing. Had the spacecraft finally slipped out of reach? Was this the end of one of humanity's greatest adventures? Not yet. But the question hung in the air like a whisper from deep space. In October 2020, hope flickered back to life. A simple message, just a digital whisper asking, "Are you still there?" was sent across billions of miles toward Voyager 2. And to everyone's amazement, it replied, not just with a faint blip, but with a full stream of data. Telemetry poured in, showing the spacecraft had reoriented itself, updated its internal charts, and even fine-tuned its gyroscopes flawlessly. After nearly 6 months of total silence, Voyager 2 returned as if nothing had happened. But what came next left even the most seasoned engineers speechless. Buried in that returning data were signals from instruments long believed to be gone for good. The plasma science instrument, quiet since the Uranus flyby, suddenly came alive. The photopolarimeter, untouched since the Saturn encounter, began reporting data again. Subsystems once set to standby were now sending updates on voltage levels and temperatures as if awakened from a decades-long sleep. It was almost like something had gently nudged the probe and flipped forgotten switches back on. Then came something even stranger. Voyager 2 normally communicates using specific radio bands, S and X, well understood by Earth systems. But now its transmissions included odd echoes, sideband flickers, and binary bursts that didn't follow the usual script. Echo pulses rebounded milliseconds after the main signal, and inside them were patterns that didn't match any command NASA had ever sent. When independent analysts dug into these mysterious data fragments, they found something eerie. Pieces of Voyager's original flight software, code written in 1977, but twisted into looping routines that referenced themselves, like a hall of mirrors inside the machine's memory. NASA officially chalked it up to a random radiation glitch, a rogue particle flipping a bit here, jumbling a memory cell there. But behind the scenes, whispers told a different story. Leaked internal notes and contractor memos hinted at a curious phrase scribbled in the margins: unknown interaction detected. Those 3 words sparked debate that hasn't ended. Could Voyager 2 have brushed against something foreign out there? Beyond the heliopause, where the sun's protective wind fades, there lies a wild churning ocean of cosmic rays, magnetic currents, and interstellar plasma. Voyager crossed that invisible edge in 2018. Some scientists describe it not as a wall, but as a skin, flexing, breathing, rippling. Could a swirl of magnetic turbulence have danced through Voyager's circuits? Or was it something far more exotic? An organized presence in space, subtle and intelligent, that saw the probe and responded in kind. Either way, the result was undeniable. Voyager 2, this aging marvel hurtling through the dark, came alive in ways no one expected. Engineers worked around the clock, writing new patches and emergency scripts to untangle the looping code. Every pulse and ping from the craft was watched like a heartbeat. And through it all, Voyager kept transmitting, steady and strange. What does it all mean? If this was nothing more than a quirk of cosmic radiation, it still reveals how mysterious and alive the interstellar frontier truly is. But if something out there reached back, if some intelligence noticed Voyager and answered in its own strange language, then Voyager 2 is no longer just an explorer. It's a meeting point, a moment of contact, a message in motion, echoing through the stars. For now, NASA isn't saying much about that mysterious, unknown interaction. Behind closed doors, teams are revising procedures, rerunning diagnostics, and debating how to file these strange readings. Outwardly, it looks like routine anomaly checks. But in hushed corridors, some engineers joke about the day Voyager 2 might blaze across our night sky, not as a silent probe, but as a cosmic lighthouse, flickering back our own code in ways no one ever imagined. Powering down Voyager 2, Voyager 2 draws its energy from 3 radioisotope thermoelectric generators, RTGs, simple, reliable devices that convert the heat of decaying plutonium-238 into electricity. Each year, these RTGs lose about 4 watts of output, roughly the power of a small nightlight. In space, though, every watt is precious. Back in the 1980s, after the Jovian and Saturn encounters, NASA began shutting off non-essential instruments one at a time, stretching the mission well beyond its original 5-year plan. October 2024. Engineers powered down the plasma science experiment, which had been sampling charged particles flowing past the spacecraft, because Voyager 2's orientation only let that instrument catch brief data snippets. Switching it off freed enough juice to keep other instruments alive for another year. Voyager 1 parallel. Its plasma detector died in 1980 and finally was switched off in 2007. More recently, in February 2025, Voyager 1's cosmic ray subsystem was powered down. Those telescopes had been key to confirming its leap into interstellar space. Now, Voyager 2 is preparing to retire another device, the low-energy charged particle detector, which tracks ions, electrons, and cosmic rays from both the sun and deep space. Turning it off should buy about 1 more year of precious data from the edge of our solar bubble. Every shutdown hurts. Deciding which instrument goes dark next is always heartbreaking, admits Patrick Cohen, Voyager program scientist. These craft have outlasted every expectation. Every extra packet of data has been a gift, teaching us about the space around us and showcasing the incredible engineering from 50 years ago. Remember, no other human-made object has ever breached interstellar space. When Voyager 2 finally falls silent, we'll lose our only ears in that frontier. Inside JPL's control room, power budget meetings are now ritual. Engineers calculate the RTG decay. Plutonium-238's half-life is 87 years, so the generators shed about 0.8% power each year and match each remaining instrument's scientific payoff to its energy needs. Magnetometer uses just a sliver of a watt but maps how magnetic fields tug and flex in interstellar space. Ultraviolet spectrometer. At half a watt, it surveys far-flung hydrogen clouds that glow under solar radiation. For now, those two instruments remain on, quiet sentinels ready to catch the whispers of deep space. While the clock winds down on Voyager 2's mission, NASA is carefully juggling what power remains. Only the most essential instruments are now prioritized. The magnetometer and ultraviolet spectrometer get short daily windows to collect precious data. The cameras that once captured iconic images of our solar system remain off. There's simply nothing left to photograph. Only the engineering cameras still check in now and then, offering views of Voyager's own antenna and thrusters, a kind of self-diagnosis during rare maintenance routines. Even talking to Earth takes power. Voyager 2's 3.7-meter high-gain antenna must stay locked on our planet, which means burning extra watts to keep the craft oriented with its tiny stabilizing thrusters. Each transmission, whether a command from Earth or data coming home, pushes the RTGs to their limit. This decline didn't happen overnight. Early on, each of the three RTGs generated about 470 watts. Today, after nearly 50 years in deep space, they're producing barely half that, closer to 250 watts apiece. Of that, only about 20 watts are left for science. The rest powers essentials, radio communications, onboard heaters, and core avionics. To stretch every last bit of energy, NASA engineers have written new energy-saving sleep modes into Voyager's software. When instruments aren't actively gathering data, they slip into low-power rest states. The spacecraft's flight computer, running on just 69 kilobytes of memory, now plays the role of cosmic timekeeper, waking tools only when their moment comes. It's like turning off lights in empty rooms to save the last few drops of power. But in space, every decision has consequences. Shutting down an instrument means risking the loss of unexpected discoveries. What if a rare solar shockwave crosses Voyager's path? Or a sudden blast of interstellar particles surges through the void? If the instruments are asleep, we may never know. And there's a limit. When total available power dips below about 157 watts, Voyager 2 will no longer be able to sustain its core systems. When that moment arrives, the spacecraft will go silent forever. Still, there's a strange beauty in this final chapter. Voyager 2 has traveled farther than any other human-made object, sailing into a realm no eye has ever seen. Every bite it beams back is a whisper from that distant frontier, proof that courage and curiosity can reach beyond our little world, armed with just a few watts and a dream. Soon the mission will end with a final transmission, a quiet farewell as Voyager 2 fades into the black. But then came the unexpected. It was a quiet Monday afternoon at the Deep Space Network when a signal flickered to life. Lena leaned over the console, pulse racing. For months, Voyager 2 had pressed deeper into the unknown, reporting subtle shifts in magnetic fields and strange echoes from the interstellar dark. Then something changed. In a cold stream of data, one frame came through. Just one. It wasn't what anyone expected. It wasn't a star or a dust cloud or a field of cosmic radiation. It was absence. A deep, silent black where there should have been stars. No twinkling dots, no background noise, just nothing. The chatter around the control room stopped. Dr. Adabio, clipboard in hand, stared at the screen. His voice was steady, but his fingers trembled as he tapped his pen. "We were hoping for signs of new worlds," he said quietly. "Maybe frozen oceans, maybe new forms of light. But this, it wasn't beauty they'd found. It was a vast and perfect darkness, a zone where even starlight vanishes, something long theorized, a place so cold, so quiet, so empty, it erases the universe itself." Voyager 2 had turned back to us one last time and confirmed that the void is real. Outside the control room, the lights dimmed just a little, but it felt like the whole world paused. Global radio telescopes fell quiet, as though Earth itself was holding its breath. The gentle hum of computers became distant noise. Lena felt it in her chest, a quiet shiver like something unseen had just stepped into the room. Voyager 2 wasn't just backing away. It felt like a retreat. As if something out there, something more aware than any asteroid or black hole, had made its presence known. If even Voyager turned around, what does that say about what lies ahead? What's watching us from beyond the dark? The Voyager anomaly. Voyager 2's voice is fading, a whisper traveling across the silence of space. Each week, NASA's antennas have to work harder to catch that faint signal, gathering whatever fragments they can before the probe finally goes dark. Behind the scenes, a quiet race is underway. Scientists feed Voyager's final data into powerful computers, hoping to unlock secrets that could shift everything we believe about the cosmos. Then, during a long overnight session, a strange pattern appeared in the data. It was just before the unexpected communication blackout of March 2020. A block of numbers that stood out. Not random static, not magnetic noise, but rhythmic pulses. Clean, precise, like timed ripples lapping against an invisible shore. Even stranger, the probe recorded subtle shifts in pressure around it. Not the usual fluctuations caused by drifting through the heliosheath, but something far more focused, like a gentle hand pressing in from every side. Speculation ignited behind closed doors. Some thought it might be a rogue brown dwarf, a failed star passing nearby and leaving a gravitational trail. Others suspected Voyager had stumbled into something even rarer, a stable corridor of altered space, a kind of interstellar bubble that bent the normal rules. None of these ideas made it to press releases, but in government-linked research facilities, simulations began running non-stop, and the results kept circling back to the same unsettling conclusion. Voyager 2 hadn't just passed through something, it had been affected by it. For decades, engineers have worried about forward contamination, making sure our spacecraft don't carry Earth's microbes to other worlds. That's why probes are built in sterile clean rooms, rigorously scrubbed of life. But this was different. Voyager 2 sparked a new kind of fear. Informational contamination. What if the probe passed through a field, some kind of structure or intelligence woven into space itself, and came away changed? What if it didn't just record data, but absorbed something? A pattern, a signal, a new code that began rewriting parts of its software from within. The question isn't just what Voyager 2 saw, the question is, what saw it? When Voyager 2's backup software blinked to life in October 2020, something strange happened. Instead of running simple instructions, it began looping on itself, commands calling themselves again and again like a code trapped in a hall of mirrors. Some engineers didn't see this as a glitch. To them it felt intentional, not just an error, but a machine beginning to act with a strange kind of will. Inside NASA's Jet Propulsion Lab, things got quiet. Behind the regular mission updates, a separate, classified team quietly took over the signal watch. Their mission? Just listen, log everything, and absolutely no replies unless specifically authorized. Why the silence? Because the signal had started acting in ways no one could explain. Its strength would suddenly spike, not because of power surges, but in bursts that mimicked solar storms, except no such storms were happening. The timing of these pulses began mirroring data from Voyager 1's early journey into interstellar space, but reversed like a memory playing backward. Whispers began to circulate. Some theorized that Voyager 2 had entered into resonance, caught in a feedback loop with something unknown. Perhaps a gravitational pocket, a cosmic field, or even an intelligence watching from the dark. Others warned, don't poke the unknown. If we reply, we might awaken something we can't control. One internal memo summed it up in 4 spine-tingling words. Maintain position. Do not respond, unless told otherwise. To the public, everything seemed normal. Press releases remained dry. No new science data this week. But behind the scenes, specialists combed through every byte Voyager 2 sent back. They ran it through deep analysis software built to detect everything from alien beacons to pulsar signals. They cross-referenced it with solar activity, cosmic rays, even distant supernova events. Nothing matched. It was as if Voyager 2's own history, Its journey, its memory, was echoing back through space in a form no one expected, transformed, rewritten. Then in April 2025, something shifted again. For just a few seconds, Voyager 2 switched back to its original frequency, the old X-band signal it used in the 1970s when it first launched. Then, just as quickly, it drifted back into those strange, unfamiliar sidebands. That brief moment sent shivers through the control team. Was it a final glitch? A nod to the past? Or was Voyager 2 reaching out, trying to reconnect, not with commands, but with meaning? No one knows for sure. But whatever is happening out there, it's clear. Voyager 2 is no longer just sending data. It's sending a mystery. NASA still publicly blames Voyager 2's strange behavior on random bit flips from cosmic rays. But those closer to the mission know the truth is more complicated. Inside closed-door meetings, teams debate whether it's worth retuning the Deep Space Network's giant dishes to track Voyager 2's increasingly unpredictable signal, or whether they should focus instead on keeping the science instruments alive for as long as possible. It's a constant trade-off, the hope of fresh discoveries versus the risk of waking something we don't fully understand. For now, Voyager 2 keeps whispering across space. Its signals carry more than raw data. They bring hints of pressure waves no model can explain, echo patterns that suggest organized structures, and strange fragments of code looping like they're caught in a feedback cycle. And with Voyager 1 sending mirrored anomalies from the opposite side of the solar system, it almost feels like the two craft are drifting along invisible paths, currents threading through the galaxy that we never knew were there. From a 5-year assignment to a voyage into the unknown, Voyager 2's journey reads like the plot of a sci-fi epic, except it's all real. Launched in 1977 to explore just Jupiter and Saturn, Voyager 2 ended up charting a grand tour of the outer planets. It flew past Uranus and Neptune, then broke free of the Sun's domain and sailed into interstellar space. Along the way, it changed everything we thought we knew about the solar system. At Jupiter in 1979, it discovered new rings, caught volcanoes erupting on Io, and revealed Europa's icy surface, cracked and broken like a frozen puzzle, hinting at oceans beneath. In 1981, it arrived at Saturn, uncovering ghostly ring spokes and dozens of moons, each with its own mysteries. Then came a long silent coast before its pass by Uranus in 1986. There it found fast-moving storms under a pale blue haze, 9 faint rings, and winds so fast they could lap a jet dozens of times. Neptune followed in 1989, where Voyager 2 saw dark spots, violent storms raging across the planet's face, and found geysers erupting on Triton, a frozen moon spinning the wrong way. And still, nearly 5 decades later, Voyager 2 is talking. Its tiny memory, just 69 kilobytes, sends data at a glacial 115 bits per second, but each magnetic reading, each thermal check, is priceless. It's a message from the edge, proof that we're still listening. Like its twin, Voyager 2 carries the golden record, a copper disc etched with greetings, music, and images from Earth. It's humanity's love letter to the cosmos, a message to anyone who might find it one day, letting them know who we were and where we came from. The mission has become a symbol of human tenacity. Built to last 5 years, the spacecraft has survived nearly 50. Engineers have patched glitches from billions of kilometers away, reprogrammed it in flight, and turned off systems one by one just to squeeze out a little more time. Thanks to Voyager 2, we now know that the outer planets are not cold, dead rocks, but dynamic worlds full of energy and motion. We've learned that space is not empty but buzzing with particles, magnetic fields, and mysterious flows we're only beginning to understand. Now, with its power fading and its voice growing faint, scientists are doing everything they can to capture the last bytes it sends. Voyager 2 has already gone far beyond its mission. It reminds us that even with limited tools and a fragile machine, human curiosity can travel beyond the stars, and that out there, in the silence of deep space, the universe is still whispering back.